Okay, live stream will start.
All right, hi, good morning. We're from BCIT, British Columbia Institute of Technology in Burnaby, BC. My name is Mike, this is Jordan, this is Allison. We're talking to you today about optimizing pedestrian access and mobility at TD Coliseum. So we looked at a study from the Greater Toronto Region Board, Toronto Region Board of Trade from 2024, talking about traffic congestion in the GTHA. We saw that a lot of residents are avoiding going shopping and avoiding going to sporting events due to traffic. And when we looked at the reason for the traffic, they cited that there's too many cars on the road, too much construction, which is one thing, but too many cars on the road, but very few people said that transit was to blame. So even though people on balance seem to think there's enough transit, they were still making the decision to not go out to those areas, which we found to be not great.
And so then taking this, we looked at TD Coliseum in specific and realized that it might be due to there not being enough walkways. And in particular, when events happen, there's a lot of foot traffic going through the entire area surrounding TD Coliseum, but not a lot of wide pathways. And so then this causes pedestrian vehicle conflicts, curbside overflow, and just limits mobility in general. And then some other things we noticed were bike facilities, just limited resources of security in the surrounding areas, and then limited nighttime visibility. From what we could see, we're not in the area, but just not a lot of lampposts around. And then the last thing that was mentioned to us at TD Coliseum was non-optimal gate utilization, so people weren't going to the correct gate, or they were just getting in a long line and not going around the corner to a shorter one.
Sweet, so this gets into our methodology section. Our main three goals were to basically take spatial statistics of rapid transit, bike paths, and the pathways around. We then perform a network analysis to determine what is the fastest paths to priority locations. This just enables us to see where are people going on the current road systems, the current sidewalks, and where can they go. So from this, we're able to determine 5, 10, and 15-minute buffer zones for walking distances to our priority locations, such as GO Transit, parking lots, bike share spaces, bike parking lots, all of these interesting things. From there, we did analysis of that, and as well as created some digital mapping layers. So from our spatial analysis results, what we determined was actually the transit around TD was quite good. A lot of things that is going on is specifically related to TD. Right now, the current city planning is moving in the right direction. We've looked at future rapid transit stations from the Hamilton Light Rail Transit, and we see that they're all within about 5 to, or we at least have 3 stations within 10 minutes walk of TD Center. So from this, I will just go over the 15-minute radius results. This was all done through buffer spatial analysis. So we determined that there's over 205 bike parking spots, 48 bike share stations, and over 23 kilometers of bikeways. As I said, there's numerous light rail stations planned, as well as we will have the Hamilton GO and the West Harbour GO. Beyond this, we saw a lot of walkability. There's over 120 kilometers of sidewalks, as well as 23 unique bus routes that pass through the area.
And so all of this data and all these things that we're seeing kind of reminded us of home, specifically Granville Street in Vancouver, where they had a lot of walking around in storefronts. And so they actually decided to permanently close down Granville Street to cars so that it would just be a pedestrian walkway. And so we're deciding to take that approach for our solution.
Alright, so from this we determined a 3-part solution, focusing on 3 main corridors. We have the Bay Street, York Boulevard, and Jackson Square. So what we're looking at is clear walkways through Jackson Square, pedestrianization of Bay Street, as well as adding another lane for pedestrians along York, as well including wayfinding tools such as real-time transit information, fencing along York Boulevard, and better lighting throughout to just create a more pedestrian feel and allow people to be comfortable in that space that was originally given to cars. So for Bay Street, our immediate goals was to continue with the current pre-event closures. Beyond that, looking forward in time, we're looking at a permanent pedestrian plaza. However, we know that logistic deliveries are also coming through, as well as transit, as well as emergency vehicles are incredibly important to get through that area. So what we're recommending is to take away 2 of the lanes going down Bay Street, and then maintain 1 travel lane that is only for authorized vehicles. So what this does is allows us to pedestrianize the space. We can bring in food vendors, we can bring in, just make the Bay Street area much more comfortable for pedestrians, as well as still allow those priority access for when people need it most.
Make it kind of a destination to be, rather than, I mean, right now it's just, we're extending space allowing for traffic flow, but we could also be making it into somewhere that people want to come down to early and spend time.
This will also help with the issues within TD Coliseum of long lines for food, as there would be some food outside, and that would hopefully divert how many people are within TD Coliseum in lineups waiting around at events.
Okay, so then we've got, that was for the Bay Street side specifically. Then for York, in the immediate, in the immediate future, we decided it would be a good idea to block off, or we consider it would be a good idea to block off the eastbound lane, the nearest to the building, during the events to kind of, we noticed that the gardens that were in the way and the parallel parking, that although it gets blocked off, there's just, it's pretty narrow there. Even during our tour we were having, some lady walked through the crowd and kind of got mad at us for blocking the path. There's just not enough space. So we thought that blocking off Bay Street that's going on right now was a good idea, and if we can give pedestrians more space to go, that would be even better. And then in the long term, to extend the sidewalk out, maybe replace the gardens with street trees, which might even help with directing traffic flow if we've got people who can walk on one side or the other side of them. And then permanently closing the eastbound lane, one of the eastbound lanes to extend out the sidewalk getting to the building.
And then the last thing was the path through Jackson Square. We noticed it was kind of dark, and so we would just suggest putting in more lighting, putting in some more trees, making a clear path, because that will then go towards the stations, and then when people egress out of the building through those back gates, they can just walk along a clearly lit path straight to the station and feel safer.
This is the James LRT station that is being designed for the future. And then beyond that, I saw that there's already, the city already has invested in, or Metro Links or the Hamilton Street Rail has invested in a lot of technologies for using sensors and whatnot to monitor traffic, or say when's the next train coming, when's the next bus coming, those kinds of things. So we thought if we integrated these kinds of technologies that already exist into the exit points at Hamilton, or at the TD Coliseum, we would then be able to give pedestrians a more informed choice about where to go, possibly give them an idea of where they're going to, where they would be, where's the most efficient place for them to leave, that kind of thing.
So what does this do for the TD Coliseum benefits? This really looks at attendees, instantly see and compares information while egressing the station. This, for Hamilton residents, this involves a smoother round trip with less gridlock. And for emergency responders, it allows access to be maintained while still pedestrianizing that space and making it friendly.
So is that,
Thank you for your time, and thank you to the sponsors that helped us get here.
Coliseum was a major project for Hamilton with the goal of increasing tourism and providing a venue capable of accommodating 18,000 people for music and sporting events. To reduce the harms of short-term and event-based travel surges on visitors and locals, our team focused on the following challenges, being increased traffic pressure during event days, strain on transport capacity, parking overflow into residential areas, and increased pedestrian accumulation around Bay Street entrances. Our objective is to improve public transit availability and connectivity for visitors while maintaining the needs of local residents. Here, we have used the provided data sets to identify key areas and services impacted by these issues. Major areas of interest to our research include the TD Coliseum, GO stations, Hamilton Center, and West Harbor, parking lots near the venue, and emergency service stations. Using HSR survey information, we identified areas of high traffic frequency which coincide with streets approaching the venue. This map helps to illustrate the current traffic and safety issues surrounding the Coliseum and the focus of our proposal. To address these issues, we have developed 3 proposed solutions. One is identify parking lot distances from the TD Coliseum, highlighting walkability and potential for new event day transit options. 2 is creation of an event-specific HSR route connecting the GO transit stations to the venue. And 3 would be encouraging GO train usage with free rides post-event and increased accessibility when using the new HSR routes. I'll now pass it over to Natalie and Bryn to run through our potential strategies.
So we used buffers of 400, 750, and 1200 meters to identify parking lots that are less than 10 minutes walking distance from the Coliseum, 10 to 15 minutes, and 15 to 20 minutes. Roads directly around the venue in red experience high volumes of traffic during events. We want to push people to park in the further lots, especially those ones down there over in the east, to reduce the congestion directly around the venue. Many of these further lots also have electric vehicle chargers, as you can see on the map, which we think can entice people to park in those lots. And these lots have been selected for developing a new HSR route to shuttle people to and from the venue.
So going on to that point, our second solution is the creation of city bus routes to accommodate the influx and outflux of visitors at the venue. We targeted parking lots further from the venue, like Natalie said, for the bus route development using buffers and street attribute features to inform our analysis. This proposed continuous route aims to divert arrivals and departures to the 2 main GO transit stations, being West Harbor in the north and the Central GO station in the south. The route is beneficial because it avoids Bay Street, which is sometimes closed on event days. Instead, it drops people off on York Street in front of gates 7 and 9, which addresses the issue of increased congestion of pedestrians in gates 1, 2, and 3 on Bay Street. Running the bus at 10-minute intervals is feasible. We mapped out the completed route and it would take approximately 30 minutes. So having 3 buses staggered 10 minutes apart would mean 10-minute intervals to drop people off at the Coliseum. You can see here that we have a proposed parking lot at the north end, which leads me into the second component of the solution, 175 Stewart Street. This is a lot that's currently being used for outdoor temporary housing for unhoused community members in Hamilton. The City of Hamilton phrases this as a temporary solution as the city works on long-term permanent shelter solutions across Hamilton. Given this, once a permanent solution in the city is implemented, which is hopefully soon, the location shows potential as a parking lot to reduce parking pressure near the venue. It's comparable in size to the City Hall parking lot that we highlighted earlier, which contains around 400 parking spots, and it's conveniently located very close to the West Harbor GO station, so our proposed bus route would have a stop that would allow people from the bus and people who drive to make their way to the Coliseum using public transit.
So our third solution is to increase the GO train usage at the West Harbor GO and Hamilton Center GO station and control pedestrian flow to and from these stations. So based on survey data from the Coliseum, there's a large portion of attendees from Toronto. Both stations are serviced by the Lakeshore West train from Toronto. The West Harbor train GO station also has a train coming in from Niagara, and the Hamilton Center GO has many GO buses from around the GTA. So the proposed HSR route will be hitting these stations every 10 minutes in that 90-minute window before events. And after the event, the HSR route will bring large volumes of people back to the stations, allowing for quick dispersal after the event and reducing congestion in that direct area around the venue. To encourage this, we want to partner with GO Transit to offer free rides home after large events. And for those who choose to walk from the station to the Coliseum, we have these walking routes, which follow the bus routes that were developed, and they're marked with signage and event staff, and are directing pedestrians to gates 7 and 9 on York Boulevard rather than 1, 2, and 3 on Bay Street to avoid congestion in that area. So here's our proposed timeline for implementing our solutions. Short term, we want to conduct initial testing of the proposed HSR route with temporary bus stops for the upcoming Disney on Ice shows and Juno Awards in March. We want to test to see the impact of this new route on parking, congestion in the area, and GO train usage. Info about the new HSR route will be shared on the TD website or emailed out to ticket holders so they're informed about this. Long term, once a permanent solution is developed for the current temporary housing on 175 Stewart Street, we can develop a new parking lot there. And finally, for event day management, there's initial setup required for signage along the walking routes, especially from both of the GO stations, and then that HSR route and that 90-minute window before coming in 10-minute intervals to shuttle people towards the venue. But based on the size of the event and also the demographic of attendees for the events, we realized that not all events at this venue will require the proposed HSR route.
There are numerous additional components that would need to be considered for the implementation of our proposal. Among these components is the implementation of directional signage and event staff, like we mentioned earlier, to aid in the flow of incoming attendees. Additionally, clear and consistent communication with transit authorities will be necessary to sustain smooth operation of the bus and train routes that we're proposing. And conveying the bus and train routes with emergency services would allow them to efficiently respond to potential emergency scenarios on the days of events. So our proposed solution would benefit several groups of people listed here in various ways. Most importantly, event attendees would benefit from the frequency and proximity of transportation to and from the TD Coliseum. Residents would experience reduced crowd spillover into residential areas surrounding the venue. Hamilton city planners are able to implement a cost-effective, time-effective, and minimally intrusive solution that has long-term sustainable results. Local transit users will be able to use regular public transit systems without additional crowding before and after events. And lastly, fewer cars parking on the streets surrounding the venue will result in enhanced resource accessibility for first responders, including fire hydrant access, improved response times, and reduced road traffic obstructions. To address the event-based travel demand around the TD Coliseum, our group proposes the following ideas. 1. Identification and utilization of parking lots and areas to direct traffic away from congested areas. 2. Creation of an event-specific bus route to ease transportation strain before and after events. And lastly, encouraging GO train usage to reduce transportation by car and downtown congestion. These 3 strategies can be implemented using majority existing infrastructure, creating an efficient, safe, and reliable solution to TD Coliseum events. Thank you for your time.
morning, judges. We're Urban Pulse Systems, Team 9 from the University of Calgary. Our names are Kush, Jaden, and Krish, and our project is a real-time mobility system for the TD Coliseum that predicts congestion before it even forms, dynamically routes users, and ensures emergency access is always protected. On big event nights, the network around the Coliseum doesn't just fail slowly, it fails all at once. You get a surge in arrivals and departures, bottlenecks at gates and curbside pickup, and guidance that stays static even when closures and gate rules change. This results in people and vehicles being pushed into the same few conflict points. All of the geospatial data used or provided to us was in the handout except for the average daily traffic count, which was from the City of Hamilton's data set. And our solution is not just an urban planning concept. It is a multi-component system that combines GIS, event mode rules, and IoT sensing and update process, and a MATLAB weighting engine to make decisions in real time. Urban Pulse system flips the area into event mode. We apply rule changes like Bay Street closures and detours, enforce gate eligibility by ticket type, and protect EMS corridors. Live inputs update routing costs, and our MATLAB weighting selects the best gate and route in real time. And this conflict map converts operational input into spatial problem areas. Using input from the venue and regional staff, we identify where congestion, curbside pressure, and pedestrian crowding occur during these major events. The hotspot layer shown in the black there shows congestion concentrations, while pedestrian corridors funnel into a small number of gates, creating these little pinch points. We also map crossings, a rideshare conflict zone near Vine Street, and municipal parking lots that feed demand into these corridors. These conflict areas directly inform our routing logic, monitoring, and event mode control. So this routing app is powered by a custom algorithm that combines predictive modeling with live IoT feedback and is designed to integrate directly into the existing TD Coliseum app. The user selects their event, ticket, and travel mode, and the system recommends the optimal gate and route with breakdown of travel time, wait time, and total time. Unlike normal routing, our system is predictive first and then reactive. Before the surge, our MATLAB weighted cost matrix evaluates 5 parameters: distance, expected gate wait time, corridor congestion, curbside pressure, and pedestrian flow capacity. Using patterns from previous events, it forecasts demand and gate loads to optimize routing for event conditions. The system then continuously updates using live IoT feedback. User smartphones act as distributed sensors, allowing the algorithm to dynamically re-rank gates and routes as conditions change. This creates a closed-loop system that prevents bottlenecks before they even form.
So these following maps show our decision engine working across different modes. So for this first one, it's our transit mode. So we're overlaying the bus routes and stops, and then generate the best route from the user origin to the Coliseum, and then to the gate, using the real transit network that we were provided. So the output includes the best path, including which stops to get on and off at, and then any walking in between. So the IoT layer are the phones that would be running the app. So every user becomes a sensor in a sense. And then the live data feeds crowding and travel time back into the model so that the system could guide people to the right eligible gate for their ticket type and redirect them away from congested corridors as the conditions change in real time. Next, we have our driving model. So we route the best parking option first, and then connects the final approach on foot. So again, the IoT layer is the phone app. It picks up the movement and density patterns and updates the cost of lots and walking links in real time. So instead of guessing, the system is actively able to recommend which parking lot to use and which gate to enter through based on the live conditions. Next, we have some of our urban planning solutions. So we use network analysis to map the walking time from the Hamilton GO station, which is the closest rail link to the Coliseum. We use the real sidewalk network to estimate time for an average person. The result is a walking time surface of bands of 5, 10, and 15 minutes, showing which corridors reach the venue faster based on network connectivity. So this is then plugged into our routing application. So the system compares the models properly, factoring in the train or bus plus walking times, and recommend transit when it makes sense, especially during event mode closures and road congestion. And then our next solution here is the staff-controlled emergency zones. So the TD Coliseum would have control over the app, and if something occurs, they would be able to shut down different zones and reroute traffic away from these zones, all in the app. So each zone would have 3 statuses. There would be active, which means it's clear and usable; closed, which means there's an incident happening and the system treats that area as restricted; and then we have the watch zone, which is like lower priority caution zones, where routing would be discouraged in our app. When the status changes, it becomes a live IoT input that updates the routing cost instantly, and then our weighting model would re-rank the next best pedestrian routes.
Yeah, so now going into how we actually implement this on event day. So about 1 to 3 days before, depending on the size of the event, we go through and load all the event details into the application, like the attendance, the gate eligibility, how many people, curbside zones, safety issues, things like that. That would kind of train our model. The day going into the event, you would publish the data sets that we have onto the application. People who, like the staff and the users, can then see it, map themselves accordingly about 24 hours before or just going into the day of the event. And then on the way out from the event, we'll switch the application to the outbound side of things so that people can go through, including our staff, and see ways to actually exit the event, whether it's transit, walking, driving, etc. And it shows all those options as well. And the day after, we save all of our metrics in terms of how successful it was, how slow people were, congestion zones that we can go and review it and fix depending on which areas struggle the most per event. In terms of how we plan to implement it, so in the first 3 months, we kind of want to go through and build what we actually have right now. So have more like the maps developed, some of the workflows, the routing engine, kind of built the IoT thing into it more. The next 3 months, we want to run more pilots on like events here in Hamilton. So different types of size events, concerts, sports events, etc. The 6 to 9 month range is when we'll integrate the real IoT signals into it. The 9 to 12 month range is when we want to expand more into different urban solutions like pickup bays and queue zones. And then the last 6 months is when we want to actually integrate the entire system properly into one interface within the current TD Coliseum app. In terms of the benefits that we provide, so within, for attendees specifically, the goal is to give them the best way to get from where they are into the stadium in a safe manner. For residents, the goal is to cut down a lot of the flow traffic in their neighborhoods, reduce congestion, make it easy to flow in and out. And then for emergency services, the goal is obviously just to have clear routes and also empty zones when they get to the Coliseum to make it easy for them to get in, but also easy for them to find where the emergencies are happening. And then we also have some general like performance metrics on the screen. And then for the summary, kind of to wrap it up, the goal is to have like one full cohesive journey. So implementing everything into one application within the TD Coliseum app makes it really easy for us to not have any additional data sets or anything. People can just pull out their phone with the current application, route themselves nicely into where they're going, no matter what type of method they're using to travel in or out. And generally, it's just to have less spillover, make things a little bit easier and safer within neighborhoods, but also make it as convenient as we can for emergency services to get in and out of the Coliseum itself. And then, so that's it.
Thank you. Apologies for the slides.
Yeah, they look
However, the local public transit system is not configured to accommodate this surge demand. So our mission is to provide a geomatics-based solution that is low cost, adjustable, and multi-pronged. So there's no feasible way to eliminate cars driving to events at the TD Coliseum due to how the GTA is laid out. However, we believe that we can redirect up to 30% of vehicle traffic to outside of downtown Hamilton on event nights.
So our solution package involves create GO Express shuttle bus from Burlington GO Station to the Coliseum. Next, we will convert one block of the Bay Street into a pedestrian and transit-only plaza, and we also raise awareness of attendees to better improve the crowd control. So for the express shuttle route, through a study, we found out that a significant portion of the event attenders are from the GTA area, making up to 1/3 of the vehicle traffic into the downtown Hamilton. Therefore, we think that if everyone's driving to Burlington, park their car there, and shuttle to downtown Hamilton, we can solve the problem of traffic congestion. According to the data from Ticketmaster, we find out that on one night of event, the stadium is expecting up to around from 8,000 to 14,000 attendees coming, and the infrastructure at Burlington GO can accommodate up to 1,700 parking space. So if 30% of the attendees is coming to the GTA and park at Burlington GO, there are 4,000 guests that are required to be shuttled to the stadium. So using network analysis in S3, we have come up with the most optimized route from Burlington to TD Coliseum. Ingress is 17 minutes, egress is 16 minutes. We also leave zone for traffic, drop off, pick up, which can make the total round trip onto 45 minutes. So let's assume a seat capacity of a GO transit bus is 80 people for a 40-minute round trip of an interval of 5 minutes. Then we can completely clear the venue after 100 minutes, and that will accommodate 4,000 people. So this is our code to find out the optimized logistics.
So the cost analysis of this solution is that we estimate 30,000 for one event evening, and this is due to labor costs, bus maintenance, bus fuel, stuff like that. However, this can be offset by adding a small $2.50 surcharge to every event ticket sold. This is a quick and cheap solution that can be implemented as soon as possible, and then we can also conduct trial runs with less buses and less service to test the attractiveness of drivers using the park and go option. For those coming into the city by train, it is a 15-minute walk to the Coliseum. However, during egress at nighttime, the city of Hamilton already operates a summer shuttle bus around the downtown loop, and we can utilize this to shuttle people to the West Harbor Road.
So the permanent conversion of a section of Bay Street into a pedestrian and transit vehicle-only zone. There are several purposes for our proposal to convert this into a pedestrian-only zone. First is to facilitate our arrival. The arrival of our shuttle buses from Burlington. Next, it is to address the congestion at TD Coliseum and safety of the pedestrians there. Finally, it is to accommodate small entrepreneurial operations in downtown Hamilton. So our proposal is just to convert one block between York Street and Market Street to a pedestrian and transit vehicle only zone. This will allow the continued access of the loading dock at the intersection of Market Street, and will allow people who turn onto Bay Street to exit onto Market Street, which we believe should be converted into a 2-lane westbound and 1 eastbound. Yes. Furthermore, when the Coliseum is not in use, this plaza can be utilized for smaller entrepreneurial purposes and revitalize this area. This is our visualization of our proposal with a bike lane, a bus lane, and 2-lane width of pedestrian plaza. The permanent conversion would also ensure access to emergency vehicles through this area at all times. They can either go through the bus lane or just drive directly onto the plaza in emergency.
So the cost analysis of this project, we estimate to be $1.5 to $2.5 million for a permanent solution. This is based on the estimate from the city of Vaughan and other GTA cities. And we can also run a small $200,000 temporary solution using just paint lines or planter boxes that is non-temporary.
So, improving crowd control. When we spoke to Celine Seguin of the VP of events at TD, she suggested there were some difficulties getting event goers to go to the gate closest to their seat. So we have some add-ons to our solution that can aid with this. First, on the shuttle, the moment you board, there are adverts all over the bus saying, look at your ticket, look at your gate number, maps all over the bus saying where your gate is, and announcement throughout your 20-minute journey blaring at you how to get to your seat the fastest.
So at the entrance of the gates, we suggest big signs with arrows to your gates, as well as maps around the plaza when you disembark the shuttle. We also suggest these changes to the Coliseum, including bigger gate numbers at eye level, as well as large signs with stairs to the Jackson Square Plaza to lead you to the upper level gates.
And we also want to utilize gate 12, 13, and 15 on the upper floor because nobody aware about that, so that gates are not in use. In order to attract more visual attention and improve mobility, we propose an escalator on Market Street. Jackson Square itself can improve visually to provide community space, so we can put garden benches and artwork to revitalize Hamilton downtown.
So in conclusion, we believe Hamilton already has the infrastructure in development that would facilitate long-term congestion from the Coliseum. Our flexible, low-cost multi-pronged solution is to address unexpected or sudden surge demands that may exceed Hamilton's infrastructure capacity. Many thanks to our sponsors, especially the Lower Mainland BCIT group, for which we may not have been able to come today. Also, other companies associated with British Columbia Lancers, McLean, Gildera, Underhill, Bennett Lancering, and of course, our student association. Right. Thank you very much.
Hamilton and the competition admins for hosting us. Thank you to TechTerra for sponsoring us, and thank you to the judges for listening to our presentation. We are Devin Hewitt,
Marcus McRae.
Joe Bermuda.
and we are students from SAIT, and we're very excited to share our ideas with you. Our strategy focuses on dynamic, data-driven solutions that support sustainable growth and development while preserving the heritage of arts and culture that make this city great. Our aim is to ensure smooth accessibility for attendees while enhancing their time in Steel City, whether it be for a day, a weekend, or a lifetime. TD Coliseum reopened in November 2025 and can host up to 18,000 attendees per event. Since opening, major acts and upcoming events continue a legacy started by its predecessor, Cox Coliseum. This reputation for art and entertainment has shaped the city, with a thriving art and food scene that makes Hamilton the best parts of a big city and a small town combined. Ticket sales by location show a clear divide. For more locally focused venues, sales are typically concentrated around Hamilton. Meanwhile, TD Coliseum has attendees that come from across the Golden Horseshoe and beyond for a chance to see their favorite band. Data suggests that up to a third of concertgoers come from Toronto alone. It is in our best interest to cater to the two main origin groups of Hamilton locals and Toronto GTA visitors by designing arrival guidance and gate distribution around their expected travel modes and approach corridors.
Okay. So our main possible issues we're facing are high vehicle traffic during events, which congest the downtown core of Hamilton. We're also focusing on EMS response times, as well as herd behavior near the three main gates causing overflow, while others are seeing not much activity. In addition, the typical growing pains of a thriving city combined with world-class mainstream entertainment threatens to make the area less hospitable for the local population, and the exodus of which would strip Hamilton of what makes it such a vibrant and interesting city. Our goals, or our desired end goals, our approach follows the framework of the City of Hamilton's strategic priorities of growing Hamilton's reputation as a leading tourism destination, cultivating vibrant tourism districts, promoting and supporting sustainability of natural assets, as well as strengthening Hamilton's major events and festival sector. We propose a solution that reduces vehicle circling/idling by improving gate distribution, promote public transit to and from the destination, more specifically within the downtown core, and improves the experience for both visitors and also the residents of Hamilton.
And so what our solution is using dynamic routing within an app to let attendees and guide them based on congestion gates and seat locations, accessibility needs, and real-time crowd conditions. So from an operations perspective, staff and emergency services receive spatial data, display heat maps and crowd densities, allowing for rapid deployment of employees, crowd control, and improve emergency response coordination. So from a geomatic standpoint, we are using geolocation and crowd sensing data, which includes features like gateway times, dynamic feedback from the Coliseum if large crowds are detected, connecting existing medical priority dispatch systems, leading to fast response times, multilingual options for guests around the world, and itinerary routers, and much more. So a key component to the solution is extending experience as well for visitors in the Hamilton area, past or pre and post concert. So attendees will get information like local dining and pre or post show to help with the revitalization of the downtown area, to reduce the ingress and egress of event goers, and incentives that we can include like dining at local places for discounts, as well as early entrance and windovers. And from an operations standpoint, we could use this in real time to enable wireless access points and GPS-based locations through fixed thermal sensors located at strategic locations. And for that, we could use our mobile devices will contribute to positional data, allowing fan movements and modeled as dynamic
redirecting pedestrian flow, accessible routes, and maintaining clear emergency corridors. After events, the same spatial data could be used to inform and make strategic decisions where crowds should be dispersed to. And then from sidewalks and congestions, this will be somewhat cleared off and improve transit efficiency, as well as maintain safe access for residents and emergency responders throughout the core of downtown.
Okay, so some of the drawbacks and benefits of our app's proposal is that the solution requires ongoing system maintenance of the app. So regular calibration of sensors, like the thermal and the thermal sensing, and a baseline level of smartphone use among fans is required. While some users may not choose, like elderly or people who aren't as keen on using their cell phones to use or engage in the app, the overall congestion reduction benefits that the app provides benefits all attendees and even nearby residents through improved crowd dispersion and traffic flow. Some of the benefits are quite substantial. Event-related congestions are reduced without physical infrastructure changes. Public transit use is encouraged to be through improved wayfinding and real-time spatial data, supports safer pedestrian movement and faster emergency response. Over time, the collected data enables long-term collaboration with the city of Hamilton to inform pedestrian infrastructure improvements, event day traffic controls, and future transit planning. Additionally, integrating the Coliseum into the existing downtown area supports daytime revitalization through local artists and vendors as an extension of the nearby farmers market to help avoid isolated event-only landscapes seen in comparable venues.
I mean, collaboration is key, basically, is the thing that we want to convey to you guys. We can go to the next slide.
And what we were going to do is manage it in 3 different phases. So phase 1 would be integration of the mobile app, thermal sensors and fixtures, as well as digital signage around the place. Phase 2 would be measurement and calibration, so using that spatial data in order to make everything more efficient. And phase 3 would be operations expansions, where we further go into scaling up operations and probably getting into collaboration with either the HSR or with Go Transit in order to get more event-based shuttles or bus services. As I'm showing this image over here.
Yeah, favorable outcomes include a reduced spillage of pedestrian traffic on Bay Street, reduced downtown spillover by keeping sidewalks and curb lanes functioning, invigorated downtown tourism, extending the experience of visitors as a whole day event with Hamilton as a destination, providing CN Rail with concrete evidence of increased ridership or need for ridership, containing crowds during ingress and egress, giving local artists and vendors an outdoor extension of the farmers market, and encouraging daytime use and discouraging misuse and crime, and a dynamic future-focused approach that prioritizes sustainability, customer experience, and resident standard of living. We thank you again for the opportunity to share our ideas with you, and we're happy to take your questions at this time.
morning and thank you all for being here. We are Team 13 and we're presenting predictive GeoAI mobility management in the TD Coliseum here in Hamilton, Ontario. So my name is Darian. I'm a third-year geodesy and geomatics engineering student.
My name is Liam. I'm a fourth-year geodesy and geomatics engineering student.
My name is Lou. I'm a third-year geodesy and geomatics engineering student.
And as the TD Coliseum hosts many large-scale events, event-based travel surges at the Coliseum create congestion, transit capacity constraints, pedestrian safety risks, and emergency access challenges in downtown Hamilton, requiring an integrated geomatics-driven mobility management solution, with our focus being on managing and predicting event day mobility demand at Coliseum through proactive congestion mitigation and coordinated multimodal flow control. So to come up with the solution we did, we took the approach that 90% of solutions or problems can be answered with 10% of solutions. So we plotted a bunch of ideas and then we plotted them on a 9-square with cost being on the x-axis and impact being on the y, so that we could focus on medium to high impact solutions with low to medium cost, eliminating anything that was too expensive or not high enough of an impact. And then we took that quadrant and we plotted those solutions again on a 4-square with the ease of implementation on the x-axis and impact on the y, so then we could eliminate anything that was just too difficult to implement. And the core evaluation criteria was, of course, ease of implementation, but also impact on pedestrians and on the environment, so that we could focus on safety and sustainability and management. And our focus area, evaluation criteria of inclusion, accessibility, user friendliness, reliability, operator burden, and maintenance costs. And I'll hand it over to Liam to discuss the proposed solution.
Thank you, Dan. So today, I'm going to go with the proposed solution. First, I'd like to get into why GeoAI, why we chose to use it. It allows us to move toward a predictive and proactive approach by integrating spatial and geospatial data such as transit demand, traffic patterns, land use, and real-time conditions. GeoAI can forecast where congestion and safety risks are likely to occur before and during major events. Our proposed solution today is a predictive GeoAI mobility management system designed to improve event day travel, reduce congestion, and protect residents and support multimodal transportation around TD Coliseum. Instead of reacting to crowding, our system uses geospatial modeling and predictive analytics to anticipate demand and guide decision making in advance. So this is just an example of our GS Pro setup, just using the City of Hamilton's website. We downloaded a bunch of just, you can see all our stuff here, so police stations, bus stops, fire stations, trails, streets, etc. I also created a venue here at the center where TD Coliseum is, just to go off of that. The next solution was then to look at the multimodal approach. So we wanted to train this AI to look at regions within 5-minute intervals from the venue. So you can see right here, we have this one here, regions walking distance from venue within 5-minute intervals, and this one is for biking. So, and right here, this is just a little buffer analysis, just what I did initially, just kind of see how we can approach it. From this, we can generate and see where most congestion will be within the inner regions, and then out towards back, also for biking, just showing the utilization of biking trails. Here we have one for pedestrian routing, queuing, and dispersal training. So right here, I initially started with looking at crosswalks. There wasn't very much data for the crosswalks to begin with, or that would show up within the region, as you can see by the little outlines there. So instead, I took a buffer approach. I did a 200-meter buffer and a 500-meter buffer around the venue, and then a bunch of street buffers around, and then on top of that, 100-meter buffers around every bus stop. From that, I kind of got a general idea, but then I created a density model right here using the network analysis tool, and this allowed me to see where most of the density of pedestrian transportation shows around the venue based off the regions outlined in this buffer section. Next, we have our resident life quality training functions. So this just shows parking lots, bus stops, roads, street center lines. From here, I created an intersect, which allowed us to show where most of the density of around and most traffic shows around this region. And then for emergency access, pretty simple, seeing closest distance for within one with respect to 5 locations. This allows us to outline which streets we should not shut down during major crowding events. And then we didn't have enough time to train an actual full model, so what I did was I did a little bit of research into how I could show some through my manual inputs. So right here we have, I created a hotspot GIBin. So with cold spots at 99, 95, 90% confidence, and then hotspots then 99, 95, 90% confidence. It's allowed me to outline, it's allowed us to outline where most of the heavy through traffic will be, so then for later purpose, we can go through and resolve any ambiguity there. And then over here, I used efficient grid and tied every feature into each grid individually that's within the realm. And then from that, the AI model will be able to go through and spatially analyze each model, each grid independently. We also proposed a few other just additional solutions as well. These are just side aspects, additional signs on the exterior of the Coliseum for the gates, which they can meet accessibility needs and redistribute congestion, and then additional maps on the exterior of the building helps inform visitors to gate locations. And I'll pass it on to Luke, who will talk about our timeline and budget.
Thank you, William. Getting into our timeline, we first start off with the procurement phase, which takes about 2 months. This involves acquiring funding for the project, as well as purchasing of software and the AI server, as well as building staff for the positions for this. 1 month would be for implementation of this, which would be creating the database, installing the AI servers, and training staff for the positions involved with this. 1 month we set aside for AI training. This will involve training the AI model by feeding it shared historical data and writing any code necessary. 1 month will be for the operational launch. The staff of the AI model is trained and the data analysis is completed. The analysis will be looked at by the staff to ensure that traffic flow analysis is being done and it is, the analysis is improving. 6 months onward is the project life. This involves further management of the system, as well as improving the AI model by adding future data to the model analysis. Getting into the budget, we broke up into 3 categories. First is software AI and AI. This involves purchasing of softwares like ArcGIS Pro, as well as the AI server, installation of the server, management, as well as staff and training costs. Wayfinding would be the purchasing and installations of the gate signs, showing where the gates are located, delegating visitors to their specific gates. Interpretive maps as well of the TD Coliseum, so visitors can determine where they are and where they need to go. An opportunity cost is the additional server if TD Coliseum wishes to further develop their AI system. Thank you for your time and considerations, and we now open the floor for any questions.
Testing, testing, 1, 2.
So we're Team 15 from Toronto Metropolitan University, and today we'll be presenting a geomatics-based solution to manage mobility at the TD Coliseum on major event days. I'm Alia Garji.
I'm Trisha Kama.
And my name is Arush Kirupakaran.
Before we get into the details, we framed our solutions around these three main objectives. The first one being realistic solutions. We focused on changes that are actually doable, not only for the TD Coliseum, but the city itself, whilst ensuring accessibility to all demographics, ranging from an older to younger audience, and people who aren't super tech savvy. The second one, smarter event dispersal. We focus on both arrivals and especially departures, aiming to reduce congestion and long queues at gates and curbsides, so attendees experience a smoother, safer exit. And finally, stronger transit preference. We want more people to opt for public transportation as opposed to private vehicles, so we could lower traffic volumes around the Coliseum, ease post-event congestion, and improve the overall flow of the network.
And the first solution we would like to propose to you guys is an app called Gateflow. So Gateflow is a GIS-based real-time gate optimization system that monitors live congestion at arena entrances and dynamically reroutes attendees to less crowded gates aligned with their seating section. So we aim to accomplish this by integrating ticket scans, crowd sensors, and spatial hotspot analysis, where the system would balance entry flow before bottlenecks form. Instead of reacting to congestion, Gateflow predicts and redistributes in real time. So Gateflow combines live ticketing data, crowd sensors, and parking occupancy into a spatial dashboard. So using hotspot analysis and spatial overlay, we identify the high density areas around gates and sidewalks. And through network analysis, the app calculates the fastest pedestrian route to the most efficient gate based on their zone that they are in. And finally, we have geofencing, which ensures rerouting avoids emergency corridors and constrained sidewalks by sending a notification to the user entering into a new zone. And this transforms a static map into a real-time spatial decision support. And next, we have the parties that benefit from our app. For attendees, Gateflow reduces entry times through real-time gate optimization and while improving safety and accessibility. For residents, it reduces sidewalk overflow and street spillbacks by redistributing pedestrian flow more efficiently. And importantly, we have our emergency responders, where it protects their emergency routes and maintains clearance corridors by preventing congestion near emergency gates, resulting in safer, faster, and more coordinated event day mobility.
And our second solution is a post-event mobility partnership initiative. Unlike Arrival, where people trickle in at different times depending on their schedule, their demographic, and their commute, Egress is almost perfectly synchronized. Everybody leaves relatively at the same time. To break that peak, TD Coliseum partners with nearby small businesses to offer post-event discounts to anyone who shows their event ticket, physical or digital. Promotions are short and time limited, for example, only valid for up to 2 hours after the event end time printed on the ticket. So instead of everybody heading straight back to their vehicle, a portion of the crowd goes downtown to eat, shop, and explore. That staggers departures over time and space, easing egress congestion around the venue while boosting revenue for local businesses, so both mobility and the local economy benefits. To ground the partnership idea in geomatics, we first mapped where it actually makes sense to offer those discounts. Here created a 500 meter walking buffer around the TD Coliseum, roughly a 5 to 7 minute walk, and intersected it with Hamilton zoning layers to pull out only the D2 parcels. D2 is a downtown commercial zoning, so these are areas already intended for shops, food, and services. All of the pink parcels within the circle are those designated D2 commercial properties, and together they form our designated partnership zone. This is the zone where we focus post-event discounts, so crowds are drawn into the streets that are meant to handle activity rather than spilling into nearby neighborhoods, residential blocks, or straight into traffic. This way, we support local businesses, keep walking trips short and realistic, and protect the quality of life in the nearby surrounding neighborhoods.
So next we have our data-driven dispersal. Right now, we already know that TD Coliseum faces a certain gridlock after every major event. So our analysis actually focuses on York Boulevard, which is a city artery that already handles 14,000 of vehicles daily. So during the egress, actually thousands of cars try to exit within just 60 minutes of post-event window time. So the Bay Street closures actually funnels all of this traffic onto York, and the intersection at York and Bay hits a 400% capacity overload. For fans in nearby parking lots, this results in a guaranteed exit delay for at least over 40 minutes. Next, we have our map-driven strategy. To fix this, we mapped out how fans are actually going to move. We have our 500-meter buffer zone. This is the blue area, which actually covers the 5-minute walk from the arena. This is also the same exact spot where fans are still on foot, walking, and deciding how to get home. So the green lines are determined using the real-time transit data. We found a 15-minute win using these green priority corridors, which are the B line, A line, and the Route 1. So this shifts all the traffic away from the red bottleneck at York and Bay. So our strategy starts before the event even happens. We reach out to both of the drivers and the commuters through pre-arrival emails as well as the app notifications. So once inside, we use the anchor nudge on the Jumbotron as well as any digital signages on site to reach the fans before they head out of the venue. So the signage displays a live time comparison, for example, a 40-minute vehicle crawl versus a 15-minute transit advantage. So we direct our fans towards the critical connectors, which are again the A and B line as well as the Route 1. So the B line moves the fans out of the impact zone and into major hubs like the Hamilton Go Center as well as the Magnab Terminal in just 15 minutes. By shifting the out-of-towners as well as the local towards these routes, we bypass the 400% overload at York and Bay. So this removes a 2.5 kilometers line of cars, getting fans home faster while also ensuring that the emergency gate 14 remains clear for emergencies.
And next we have the implementation process for the Gateway app, which occurs in 3 phases. First, we have the pre-event, where we would map pathways and emergency routes to ensure they are undisturbed, integrate ticketing systems, and establish congestion thresholds for each gate. And on event day, the dashboard activates before kickoff to predict arrival surges, classify gate congestions, and push rerouting alerts in real time. And post-event, we would validate predicted versus actual flow and recalibrate routing weights to improve model accuracy for future events. This ensures the system is adaptive, scalable, and operationally realistic.
To wrap up, the timeline shows how our 3 solutions come to life on a real event day. As fans arrive, they check the Gateflow app to see which entrances are the busiest and are nudged towards the less congested gates that's still convenient for their seating. After the event, they have 2 clear paths. They could join the partnership initiative, stay for bites, dodge the lights, using their ticket to redeem post-event deals at nearby businesses or choose to beat the rush with smart transit to get the most efficient transit way home. Together, this sequence turns one big surge of people leaving all at once into a managed staggered flow that supports local businesses and keeps traffic moving. Thank you for listening.
Okay, hello everybody. We're from Simon Fraser. I'm salon associate.
Jeffrey.
Sam.
Hello.
And so, given our proposal, we have to look at the transportation and logistic challenges associated with large-scale events at the Coliseum, the TD Coliseum. So the TD Coliseum is located in Hamilton, obviously where we are, and it's located southwest of Toronto, and it's a fast, rapidly growing city. And so their new Coliseum that was just recently reopened from renovation holds 18,000 seats and holds oh my gosh, and holds many concert, sports, and community events that lead for lots of logistical problems with people coming from out of town, from people on the sidewalks, and transit strains, of course, from people coming through the city and out of the city. So this is our proposal. The Hamilton event flow, a multi-layered geospatial model for park and ride optimization and event mobility management. So the main problem that we saw was many people from out of town coming to Hamilton for this event, and with minimal parking lots for those people to park at. So our solution was park and rides. So since car usage is unavoidable, we can find a way to manage car rides so that it can reduce the negative impact on the community around it, and make it easy access for people out of town to come to the event and not get trapped in long lines trying to get to town and out of town. And yeah, that's reducing city congestion. We looked at other solutions, but active transit can be harder when it's cold and it's hard to navigate weather, and also the ownership of the rail service that we found out it's hard to rely on transit, especially in the evening, so we didn't want to rely on that. And large infrastructure projects can be really costly and take a long time, so we want to find an easy solution which a parking lot and a ride service can accomplish.
Right, so we use 3 different layers to decide on our sites. We have kernel density from TD Coliseum coming from downtown. It goes a bit past the 7-kilometer buffer. And we also have site suitability based on lot area from the parking bylaws map from Hamilton.ca. Not too big and not too small. Bigger yellow is more perfect. And then kernel density on highways, of course, with higher density around highway exits, because we recognize that people come from outside of Hamilton to attend these events. So here's it in a nice flow chart. We decided on that 7-kilometer buffer by using average bus speed data from the city of Hamilton, 50 minutes, because we felt that was like a good time for people to travel for these parking rides. We then filtered to plots with industrial in name from the zoning bylaws document, and excluded hazard sites, like zones zoned for hazard sites and can't be used for anything. Chose a moderate sized plot so it's easier to acquire. And we excluded the downtown area because it's kind of silly to put this in the downtown, and it's quite expensive to do so. So we found 3 sites. Site A is currently Coots Drive and Dundas Street, about 30 minutes on conventional transit today. It'd be a bit less if we had an express shuttle. Site B is Victorian Ferry. It's kind of situated next to an abandoned rail line, which could be a staging point for GO trains late in the evening, currently in grassy field too. And Ottawa and Beach Street, again another grassy field, and about 20 minutes for the transfer, so it'd be a bit much less with that express service.
Yeah, and these are all at 11:30 p.m. here in the evening.
Yes.
So this is our suitability map. So just a brief overview, suitability maps are just, we combine those 3 maps that we use, those 3 data sets, and we've put them together and we've assigned different weights right there for Site A, Site B, and Site C. So it goes from 5% to 98% there. There's nothing at 100, nothing at 0, obviously. So we had different weights. We thought the most important thing was that we want it to be in that 7-kilometer buffer, because we don't want people to come and have to try and transit too long, because then they're just going to come to the downtown core at that point, right? So we had that 7-kilometer buffer at 50%, and then the highways and the size we both set at 25%, but in a more comprehensive model that can obviously be adjusted. So these are our areas, as you can see in the light colors, and the dark areas are the ones where unsuitable. These are way too big right here in the corners, and some of them are a little bit too small. So what I did is I used Python and MATLAB, a little bit of statistics to calculate kind of this normal distribution here and inputting numbers kind of based on the time it takes for people to arrive into Hamilton. Because the gates open at 90 minutes before the show, but the thing is people are not arriving here from Toronto, from Mississauga, from other places 90 minutes before the show. They're coming approximately, based on some studies we've seen, 1.5 to 3 hours beforehand. So we made this, and the mean is 90 minutes. We set a 20-minute standard deviation. So it goes from 0 all the way to 175 here. So obviously at the very, very tail ends, people come like super early. Maybe they want to make it a day trip, or they come super late, like maybe a couple minutes before the show. But most people will just kind of be here in the middle. So we had a little bit of a case study. So in the case study, we estimated that an event maybe approximately 15,300 people. So that's in between what we spoke about with someone from the venue. Between 13 would be kind of a mid-size event, and 18 is a max size, someone big like an artist like Twice, or someone big coming. So we have 2,700 park and ride users for our scenario A. This is our mid-size scenario. Notably, this is not going to be cars, but drivers. So we have peak 1,836 people arriving 60 minutes before the event, and then we have a small amount of people arriving at the extremes. And so for this, we had an 80% bus load across the whole time span. And so on our scenario A, we required 29 shuttles over that time span. So that's about 6 minutes per shuttle. And it's something that can definitely be, we believe, could be manageable under the municipal contracted fleet, and we might be able to add a few more buses. And at peak, we would only have 5 to 6 buses. For scenario B, we had 5,000 park and ride users. And under this scenario, we had approximately a bus every 3.5 minutes with a peak bus deployment of 9, which is still, we feel, to be potentially doable. And it obviously depends how many people carpool, but we anticipate most people coming into these type of venues are not buying a single ticket. Most are 2 to 4 tickets. So could it be around 1,350 cars saved in scenario A from entering the downtown core? And in scenario B, we had about 2,500 cars saved from entering the downtown core. Just, you guys obviously know what Hamilton looks like, but just to give you a brief overview, this is it, because I'm going to overlay this. So this is an isochrome, so these lines here are connecting different areas of time. So ideally, we want people in these blue areas here. So this is 5 to 15 minutes of bus ride time to the venue, and we want to avoid people coming in from the yellow, the orange, and the reds, because like I said earlier, they're just going to want to end up parking downtown if that's the case. So pre-event, we want to incentivize park and ride by charging people more money to park in the city. This is something that's been done in Calgary and in places where transit has been successful, like BART in Seattle, or in San Francisco, sorry. We want to give people who park free shuttle access. We don't want them to have to scan or do anything like that. We want them just to be able to get on the bus. We want them to have real-time parking availability to get into parking really quickly. During the event, we want to close off streets to have a little bit more of a nice atmosphere downtown and remove congestion. It also helps with emergency vehicle access. And floor attendees can be able to get to their stops faster. After the event, we want shuttle departures, just so people are not congesting the parking lot at the end. So we want them to be staggered every 5-10 minutes on the way out.
And these are just main points and benefits for the park and ride that we have. And I see your references.
And just if I have 10 more seconds, one thing that we did explore that we didn't end up getting to is agent-based modeling. So agent-based modeling takes particular agents from the that are leaving the venue, and they're modeled by density depending on the exit, and we kind of briefly did it. We didn't have too much processing power, so it's not something we were able to fully explore, but that could be something just to see a baseline scenario of people leaving without any, without this park and ride, and then we can model it again after the park and ride just to see how the density is spreading out and what improvements this makes. But yeah, thank you guys so much for listening to our presentation here, and these are just the references that we had.
Alright, so hi, I'm Ethan. Beside me is
I'm Ben. And I'm Skylar.
and these are our strategies for mitigations of event-induced congestion around the TD Coliseum area. So our solutions that we propose were organized into first mile, last mile, and future developments. For our first mile, we are proposing HSR shuttle buses. For general crowd management around the last mile, we are proposing GIS instant apps web mapping development, just as a general idea. So as a general preface for the TD Coliseum area, new solutions are most needed for the near house capacity events, so example, the recent Paul McCartney or the Nine Inch Nails shows. So for this, we are focusing primarily on the larger events, nighttime shows, the ones that start around 7:30. Reduced implementation where only some components are implemented may be suitable for the events that don't draw the full 18,000, so as I previously said. Metropolitan often runs additional late service trains for major events such as the Blue Jays and concerts at the RBC Amphitheater or the Budweiser stage. These late service trains allow us to design compatible transit operations to optimize for efficient movement of fans and the mitigation of traffic problems associated with major events. Research at the TD Coliseum has conducted and indicated that primary source of eventgoers is Hamilton, as well as the Aldershot Toronto Central Economic Corridor area, the Lakeshore West Railway runs. Following this is also the Guelph, Kitchener, and Waterloo line as well. The planned shuttle service is inspired by the local Hamilton events that also provide free shuttle services, such as the Hamilton Tiger Games and the Wine Peach Festival. This would enhance the first and last mile connections for travel around the general Hamilton area.
Alright, so our first shuttle hub that we're proposing is located at Lime Ridge Mall. We chose Lime Ridge Mall due to it being accessible to the majority of Hamilton Mountain residents and Ancaster residents. Lime Ridge Mall also has a lot of open parking spaces for cars at that time, since events usually start around 6 or 7 p.m. Lime Ridge Mall is also used by the Hamilton Tiger Cats as a shuttle hub for their games. To make the maps, we used service areas network analysis and generated isochrones illustrating the appropriate distances and populations served by the hubs. We added a barrier starting at the escarpment and running along Gage Street, cutting off downtown Hamilton, just due to their location close to TD Coliseum and other bus routes that can service them easier than the shuttle would. We found population statistics through the dissemination areas census tracts of Canada from 2021, where we found that this shuttle hub would service around 320,000 people, and they could all reach Lime Ridge within 15 minutes of driving. All shuttle hubs that we will be talking about in this presentation will have drop-off at the McNabb Transit Terminal, which is close to TD Coliseum and already has built up infrastructure which won't impede roadways like King Street. And environmentally, this solution will reduce traffic in the city downtown, thus reducing emissions from vehicles.
The second shuttle hub that we located was Eastgate Square, so this is located more on the eastern Hamilton Stony Creek side. It provides roughly 4,350 parking spaces for these people. It also kind of tends to some of the upper mountain area as well, as transit kind of can go straight down through Centennial Parkway. This area has already previously been used for Hamilton Tiger Cat Games as well as the Wine Peach Festival through the free shuttle service as we previously mentioned. The map shows the same network analysis method, the same barriers utilized as well, yielding a population of around 255,000 residents within the total 15-minute drive. However, as you can see, some of the southwestern portion of the map will overlap with the Lime Ridge service there as well, meaning that residents will have the option of switching between the two areas. Given data from the Hamilton Tiger Cats shuttle schedule, buses typically started around 2 hours before the kickoff. So we're just proposing that for TD Coliseum, for shows starting around 7 o'clock, shows starting, not doors opening at 7, that they start roughly 2 hours beforehand. This gives a wide demographic of people to show up before if they want to go to restaurants or things of that such. And after the show ends, again, because everybody is kind of leaving at the same time, we estimate roughly a 30-minute to an hour window where everybody can get on transit to get back to where they need to be. And this probably leads to around 12 p.m., seeing that shows end around 11 o'clock. And yeah, again, they arrive at McNabb, and then they will also leave from McNabb to the transit hub that they're going to.
Yeah, and our last shuttle hub is located at the Aldershot GO. We're proposing to utilize the Aldershot GO instead of relying on Hamilton's West Harbour GO station. This is because the West Harbour GO station doesn't typically have many late running trains. While Aldershot regularly has late and more frequent trains during weekdays when concerts will run. Another reason is that Aldershot GO is a nexus that connects all of the GTA and the Kitchener-Waterloo areas and Guelph, while still only being a 13-minute drive shuttle ride to the TD Coliseum, which is still shorter than a walk from West Harbour GO. And then, as you can see, can't really see, but Route 17 on the bus goes straight to Aldershot, and then as well as the Lakeshore, which connects to Union, which connects everywhere.
Now, on to our last mile segment. A large problem at TD Coliseum is crowd management on the day of the event. When we spoke to the Assistant General Manager of TD Coliseum, Celine Seguin, she reported that a significant proportion of the people who attend events at TD come in at 3 gates, just on this corner here, and it is a massive bottleneck for crowd management on the day, and they struggle to relocate people to get them to the gate that may be located closest to the seating where they are at, or just spread them out to efficiently utilize all the staff that are present to help usher the crowd and the doors that are open to help them find their seating. An additional problem is that some of the demographics vary on a show-by-show basis. So for example, when Andrea Bocelli played, a lot of the crowd was older and could have been best served by the accessible entrance located on the northwest corner here. So our solution is to use an instant app from Esri to create a web application and use URL parameter encoding to place a customized route that we have determined onto the ticket, so that the person can simply click this link and have this open in a web app and guide them to the entrance. And we have made it quite obvious what entrance we would prefer to be used in this instance. Of course, the model we use to assign entrances on a per seating section basis can be adjusted as we gather more data moving forward. And in terms of future actions, there's a lot of little tweaks that could still be made at TD. One major action item that we propose is the formation of a collective bargaining association to lobby for the development of railway infrastructure along the Lakeshore West corridor. This is something that's been in discussion at the government for quite a long time, and it's been stalling out a little bit. There are lots of venues in the area and people who would stand to benefit from this, and we think the expenditure of resources in that aspect could lead to an improved experience for all of the substantive event venues in the area. And I will leave it there. A lot of small tweaks that would not be terribly applicable to the geomatics aspect of this, but was something that we would present to Andrea Seguin in person. So I'll leave it there, and if you have any questions, feel free to ask.
Hi, we are Team 10 from the University of Calgary. My name is Ante, this is Charlie and Nicole, and we'll be here to present our approach to event mobility at the TD Coliseum. So we are presenting a solution that answers the ask to develop a strategy to mitigate the transport, mobility, and logistics challenges that may arise during a large-scale event at the TD Coliseum. We'll be discussing what we considered and our approach to the main solution, as well as the actual solution, along with the timeline and potential impacts. So our solution is designed to be gradually implemented. Our solution is designed to be gradually implemented in order to support and help shift attendee behavior towards safer, more sustainable, and more efficient practices. We're proposing immediate solutions as well as long-term ones to help reduce risks, while utilizing available infrastructures to reduce the costs. The phases allows for the changes and coordination to be tested so that the best practices are implemented, and each phase is designed to address parking, transit, traffic challenges, as well as ingress and egress.
So let's start with phase one. We'll be focusing on optimizing existing municipal parking through spatial traffic control and coordinated management with parking authorities. And we'll be controlling road access for vehicles and transit buses with increasing frequency of free on high demand routes for this area. And then this is based on for every 10 minutes for peak event time. So this is for like full capacity events. To improve ingress and egress efficiency, we'll be using external signage to direct attendees to their appropriate gates based on their sectional seatings. And we'll have some movable signs placed in high traffic areas to further reduce confusion and improve pedestrian flow. And we'll be integrating this with Google Maps to provide real-time routing to available gates, supporting faster and more organized entry into the venue. So starting with phase one, we focused on optimizing existing municipal infrastructure. So we identified the convention center and city hall as being those optimal locations where we can support early phase development. And both of these sites together have about 1,000 lots that are available. So we can still maintain municipal revenue through a collaboration with them. And these lots will operate as like a single entrance to these sites so that we can control the entrance and exit flow of traffic, and we'll have on-site authorities like directing people if the lots are filled to avoid traffic. Then we'll also have a pedestrian-only routing, which will be so that we can maintain safety for the pedestrians as well as for security reasons. Police and EMS are easily available to arrive at the facilities if necessary. Then we'll also only have transit access routes, which are based on making sure that we don't have all these rider shares and Ubers like blocking traffic for everyone. So only transit will be going. We'll have increased frequency, which was based on the analysis of what routes are traveling down these roads the most, as well as what can bring people to the Coliseum the fastest. As well, we have unrestricted access to our EMS, police, fire station services, and because we've reduced the traffic of private vehicles, they have even easier access to the environment if necessary. So there are some route changes because of our development, but these are only going to be affecting some traffic corridors for small sections. And then for integrating our gates into Google Maps, it makes it easier for people to actually travel to the gates that are assigned rather than just having a single location.
So in phase two, we are introducing another parking hub at Lime Ridge Mall with a capacity for about 4,000 vehicles. This lot offers the largest parking volume within a 15-minute radius of that venue. Our data projects an estimated volume of 3,000 vehicles at peak venue capacity. This estimate is based on regional demographics and the assumption that all attendees that are traveling kind of from Toronto to St. Catharines will average about 4 passengers per car. To streamline that traffic flow, the convention center will no longer be available for event parking to encourage them to park somewhere else, and to encourage people to use different kind of behavior, different types of transit. We are going to do shuttle service connecting the mall to the venue, as well as encourage public transit over personal vehicles. Go Transit tickets will now be included with every concert ticket price. So for those opting for taxi or rideshare services, we are designating a dedicated 5-minute drop-off zone at York Boulevard to prevent congestion. And finally, phase two marks the launch of a mapping app, and this tool features interior navigation of the Coliseum, which provides attendees with a path from their entrance directly to their seats that I will show you. So here we have the map. We conducted a spatial assessment of municipal parking meter locations to kind of identify areas with that pull-over infrastructure that does not conflict with the planned road closures. The best location identified is close to the venue, and will temporarily be repurposing that curbside space for controlled drop-off and pickup activity while minimizing any disruption to that traffic flow and pedestrian safety. We also have here the location of the mall, just in relation to the event venue for that visualization of how close it is.
For phase 3, the biggest changes is that we were planning to close all the parkings that are close to the Coliseum and rather just make the only one available at the mall, where there is still the shuttle service. We still have the drop-off zone, and the roads are still closed, and we still have the tickets included, which should hopefully discourage attendees to bring their own personal vehicles. Additionally, we have a idea that we should update the actual app to integrate not only the local indoor localization, but also use the ticket information so that the attendee can see the best recommended route from where they're from to their seats.
So this is just an example of a full capacity venue, like operational timeline for like a day event, where you're starting with having your section parking, you'll have your road closures, your shuttle services running all the way till the end of the event. And this reduces downtown congestion, and it's going to be minimizing those disturbances to nearby residents because we moved to the mall. And then we also just have 3 primary like case scenarios of like where our attendees are traveling from. So we have our first one is our public transit, who are going to be providing the free GO ticket service, and then we have our people who are driving to Hamilton, who are going to be utilizing our shuttle service now to reducing congestion, and also our rideshare who now have an optimal area for their drop-off and take-off zones.
So some of the benefits of this system is redistributing that parking and prioritizing transit. We can reduce some downtown congestion here. We're expanding the pedestrian-only zones, helps a lot with public safety, reduces that conflict between vehicle and pedestrians. And again, we're increasing transit revenue, reducing that vehicle spillover into residential neighborhoods as well. So this approach creates a smoother event operation and more efficient crowd dispersal, which minimizes disruption to the nearby area and helps with emergency access. Obviously, there are some issues. Not every plan is going to be perfect, and so we'd like to kind of address a couple of them now. Successful implementation requires a lot of coordination between the city, the Coliseum, and everyone involved. The effectiveness may depend on the event type and audience demographics, and expanded road closures will result in temporary rerouting. However, this is a phased structure, and it allows for that scaling based on event demand. So you don't have to use every single strategy every single time. And so in conclusion, our multi-phase strategy provides that scalable, efficient framework, and our approaches balances event success, public safety, and resident quality of life, which creates a sustainable mobility model for the TD Coliseum.
All right, good afternoon. Today, welcome. We're going to talk to you what we believe could be the transformation of the TD Coliseum experience in Hamilton. We're all from the Southern Alberta Institute of Technology. My name is Brad Senex.
I'm Morgan Matwee. I'm Abdullah Ghazal.
And to kick things off, we'll talk to you about, we have a problem, we have a strategy, and we have our solution. I'm not going to dwell into the details of the problem because it's the same problem everyone's been trying to solve all day, but just to mention, we do appreciate that there's a lot of people coming from Toronto and the outside areas into Hamilton, which is creating a bigger, a greater congestion problem with both pedestrians and traffic. So what we've tried to do is just improve the overall experience through the application of some innovative geomatics tools. So our solution then is to really use the fusion of multiple different sensors to bring them all together using the Internet of Things, AI, machine learning, and ultimately to help inform better decision making and improve safety for everybody involved.
Yeah, so when you have a large event crowd, you have unpredictable crossings. So regular crosswalk signals unfortunately don't work for surge conditions, as it causes a lot unsafe crossings as well as transit delays. So what we propose implementing is a dynamic passive pedestrian detection system that uses infrared or visible cameras, radar and LiDAR. So it would detect people waiting and people still crossing the crosswalk. A study done in Bellevue, Washington shows that the use of LiDAR reduces inaccuracies in pedestrian detection, which leads to a smoother traffic flow. What it essentially does is it automatically extends or shortens the time of for pedestrians to cross based on the demand on the crosswalk. And as you can see here, the radar is constantly scanning for pedestrians, and the use of radar and thermal cameras actually also takes into consideration the safety or the privacy of the public. So we also want to implement the same system for data collection using radars and infrared and visible cameras and LiDAR, where it would count the pedestrians at the entrances of the Coliseum and along the routes towards the Coliseum, while also estimating wait times by measuring movement direction and speed. And the Coliseum management would use this data to identify choke points in real time, and also redirect the crowd using signage, which will reduce congestion before it forms. And as you can see here, this would basically be a screen line where it shows using photogrammetry, which it would show the direction people are and the count of people going towards and away from the Coliseum.
Now, how will all these people be getting downtown? A lot of them will be driving. But what is the worst part about driving? It is trying to find a parking spot in a very busy area. In order to improve this, we recommend that you add in cameras such as photogrammetry cameras that use AI and smart learning into previous infrastructure that will count the open spots that are available and use that data to put it on a little screen outside of parking lots to make it easier for pedestrians and drivers to know if there's open spots for parking. In 2023, Toronto had a Transportation Innovative Challenge where they have a report that has data that proves the effectiveness of in-ground electromagnetic sensors, low-resolution and high-resolution cameras that tracks parking.
Okay, so what could this look like for both the TD Coliseum and the city of Hamilton? We envision like a centralized dashboard that can both be rolled out to the attendees, or maybe there's festival attendees in the summer, they're coming in looking for parking, so the city can leverage all of this data, but it would integrate the parking data, the traffic data, and some of the pedestrian data specifically around the TD Coliseum, so we didn't get the entrances 1, 2, and 3 right at the front getting overcrowded and all the other ones being underutilized. So in addition to that, it would provide the city with comprehensive data collection that would allow them to better manage their traffic systems. One of the other ideas we had was some LED signage, and that could be either on the entrance to the city, identifying what parking areas may or may not be free, but also signage on the TD Coliseum, maybe over the entrances, listing the wait times for the different entrances based upon the information we're gathering. And the picture here is just kind of showing how that flow might occur. So what we did to help look at what was existing already within the city of Hamilton and what could be added, we looked through some of the data, public data available, and specifically looked at the average daily traffic, which is in blue. The thicker lines represent busier streets, the thinner ones less busy streets. And then also the location of the intelligent traffic systems that the city of Hamilton has deployed in over 300 intersections across the city. And if you notice here close to the Coliseum, there's really only one of those. So maybe some additional ITS systems in around the area would improve things. And additionally, maybe some cameras on some of the main arteries into the city to give you a better idea of how traffic fluctuates with the different events that you're hosting. And just one thing of note, there are studies out there that show up to 30% of your traffic during an event, people looking for parking. And if you can cut that back by even a small percentage, you've reduced the traffic volume, you've improved public safety, and so on.
The benefits of using this integrated approach that we have described will lead to more information going to the public. This will decrease the traffic, which will make it far safer for the public, as well as this will lead to a better customer experience for people going to the TD Coliseum and will make them want to come back and enjoy the beauty that the city has to offer. We'd like to recognize the people that made this opportunity for us to come here possible and would love to answer any questions. Thank you for your time.
everybody.
Wait.
Oh. I'm too ready to go. Okay. Hello, everybody. My name is Alita.
My name is Oscar.
My name's Jess.
And this is our project solution, which is about mitigating transit surges through mobility optimization at TD Coliseum. There we go. So our project approach is to go through starting at looking at the event days currently and what the realities of that are, and then go through our three-pronged approach, which is safety zoning, traffic rerouting, and new event shuttles. So for the introduction.
So the issue is that we are expecting traffic surges of 18,000 people around ingress and egress times around the Coliseum. So our primary objective is to maintain residents' quality of life by rerouting traffic, implementing safety zoning, and improving access to transit. So by doing that, we can improve the concert goer experience without it being at the cost of local residents.
So as for the current infrastructure, there's no speed limit changes in place. It's all the default 50 kilometers an hour in the certain area. As well, there are limited traffic diversions and limited pedestrian exclusive spaces. And so our belief is that this can be improved upon, which is why in this presentation we'll discuss our methods of improving upon that.
So to start looking at safety zoning, we created a buffer map, which is a pedestrian focus map, which starts with the initial radius shown in the red here. It's slightly altered to match our traffic rerouting, but here highlights the area where we're proposing pedestrian-only area, so no traffic in. And then around this radius, we have another 500-meter ring that highlights our proposed slow traffic area. So these were done in tandem with a data table which we added onto the Hamilton street lines data that was provided open source, and then we added some zone fields for the zone types and then also the traffic permitted in the area. So that would look like a zone type would be pedestrian only, and then we'd have the corresponding no traffic, and then reduced traffic, and then the corresponding speed permitted in that area would be 30 kilometers per hour. So, and then in the blue surrounding this area, that's kind of where we have the normal traffic flow, which is 50 kilometers per hour. We decided to do this because we feel like it will increase pedestrian safety in the area by encompassing all the most immediate bus stops right at the TD Coliseum. So it will allow for better mobility in that area for people walking around before and after events, servicing all like the business in the area, as well as allowed for easier traffic monitoring and enforcement in the area, and then slowing traffic. We thought of this as a way to smooth kind of the traffic going in the area to stop typical high intensity stop and go congestion. So that is our buffer map.
Yes, so for traffic rerouting, my solution was to, you want to just go to the next slide? So we found that the majority of people through a recent survey attending events at the TD Coliseum are actually coming from the municipality of Toronto, and so a lot of people will be driving to events on event day, and as such it's important that we focus on a vehicle management system. And so the way I went about doing this was by taking a spatial data set of the city of Hamilton of the street center lines, and as well as a data table of the daily car traffic on each road in the city, and using some basic SQL strings to standardize the names across them. I was able to join them together to create a choropleth street map with 5 bins. The orange is the roughly the mean total car traffic per day, with the yellow being the first and second standard deviation below the mean, and red and dark red being standard deviations above the mean. And as well, I mapped out the one-way streets as well as their directions in order to determine roughly where we should implement road closures and rerouting and detours. What we determined was that the most optimal street to close off was York Boulevard from, I believe it's Queen Street all the way until Bay Street, and or a little bit after, with an opening around this entrance into Vine Street, which is the Uber drop-off area, which allows people to access that. But the idea was that if we can close off this stretch of road, because it is one of the least trafficked arteries, major arteries around the TD Coliseum, it is the most sensible road to block off to decrease congestion around the Coliseum to improve pedestrian safety. So as Alita mentioned, this area already we plan to have a good portion of pedestrianized, and just the rest of the road generally just closed off because there's not really much to access around the area. We also converted both of these streets as of right now. One is going up towards York Boulevard, the other is going south towards King Street. But we have converted just the both of them to be one-ways towards King Street because just to funnel people back away from the closed street. And just to address any concerns about, obviously this is great for Coliseum attendees and also the neighboring residents. But as for business owners, we took a look at the businesses along this stretch and determined that the ones that would be open around the time of most events, which would be quite late, are fast food restaurants, which are actually tend to benefit from the 18,000 people on foot coming right out of venue. And so we roughly came to the conclusion that this would knock ruffle any feathers with any potential parties. There's not a lot of disinterest, we theorized. And just lastly, we also, normally they open up, close off Bay Street. We left a little bit open for access to the parking lot, as you can see on that gray square right there.
So the last solution is our event shuttle. So to account for the rest of the traffic coming in from Toronto via transit, we're proposing a new bus route, just modifying the existing 20 A-Line Express from HSR, and keeping only 3 bus stops at West Harbour, at the Coliseum, and Hamilton Go. So this removes the cost to train drivers a new route by just keep removing existing ones while improving connectivity with existing transit lines. The Lakeshore West services Niagara to Union, and from Hamilton Go we have the Go buses servicing areas of Toronto such as Union, York, Scarborough. Digitized the vector polylines for the data source from Metrolinx, and the city open data. And yeah, we wanted to increase the frequency from 15 minutes to every 5 minutes within an hour of ingress and egress. And yeah.
Thank you.
Okay, so managing event mobility at the TD Coliseum for Team 16, Carlton. I'm Ridley.
Harleen.
And I'm Derek.
Okay, so we have two main ideas. So our approach was the regional intercept parking system and the TD app rework, and we have a few smaller ideas. So first, I made a little map. This is just showing the attendance distribution for the TD Coliseum events, you know, the cities and the areas. Toronto is the biggest, second Hamilton, and then western, southern, and northern. As you can see, but most people are probably taking their vehicles, maybe some by a GO train, but most will be by vehicles. So the regional intercept parking system, so we propose a partnership with McMaster University, Mohawk College, and/or Redeemer University. So instead of concentrating thousands of vehicles within the down core, we want to redirect them to the outside of downtown. As you know, parking spaces are already maxed out by either the residents, the local residents, and/or the business services that are already there. So our main suggestion is McMaster University. It's on a great spot, right off the highway. It's along all the inbound routes from Toronto. It has already lots of parking supply, it has reliable transit that's built there. It offers both geographic advantage and operational flexibility. It's a short bus ride from here to there. There's dynamic options based on demographic that we can shape it for.
And this map over here shows a shuttle route from TD Coliseum to Lot M on McMaster, and we're right here in Burke Sciences building. So we'll have shuttles running along the route over here at 10 to 15 intervals from Lot M to TD Coliseum. And over here you can see Mohawk College and Redeemer University on this inset map right here. Those ones are harder to get to just because Mohawk College is geographically challenged because it is on the escarpment, and Redeemer University is in the southwest. So those are options for other communities around Hamilton, but for GTA, McMaster University Lot M seems like a better option, and university parking lots are usually quieter too in the evenings, weekends, when most events would be at the Coliseum. And getting to the event at TD Coliseum, usually event goers go staggeredly. So, you know, you get to the event slowly, everyone has their own priorities, and when the event ends, you do get to, the event ends at the same time, so you can have buses queue along the line over there and lead visitors back to McMaster. And pricing, so Lot M has a flat rate of $4 compared to other pricing options near TD Coliseum, which were options were given as Bay Street Parkade, Hunter Street, and Jackson Square, which are more expensive to park at. So Bay Street, Lot M has a cheaper rate, and also visitors would contribute to the Hamilton Transport too by taking a shuttle. So it's a benefit for both McMaster and the city. And as I said earlier, shuttle services would be staggered going to the event and have buses queue up going back to the event afterwards.
So safety consideration, safety for the attendees is a top priority. So as you are crossing the King Street and the Main Street, two huge streets, we highly recommend increasing the police presence there to help with the attendees' traffic and the movement of them from the shuttle stops to the TD and then back again.
Yeah, and the second part of this is the TD app rework of the TD Coliseum. Currently, as it stands, it has an integrated map where it has a static layer showing you everything from the concession stands and the overall layout with the gates. But as it stands right now, currently what happens is a lot of visitors that come to TD Coliseum tend to go for these front three gates and ends up having these long queues and congestion at the front. So our idea is to improve on it, and for that, we're looking to create a GIS integrated venue map as well. So for that, the idea we have behind this is to create a integrated interactive map that will look to optimize the foot traffic from the gates to your selected seating based on your ticket and your seating selection. And so far, this is what we have. So, sorry. No. So here it is. Right now we have just a standard foot layout of the TD Coliseum. This is based on the second floor layout, and here we have the entrances from the east side, north side, and a little bit from the east side. And this is kind of like what it looks like as of now, where it has the seating layouts, the entrances, the VIP entrances, and all the confectionery stands as well. But our idea would follow upon having a kind of something like this, where it'd be a optimized layout. Kind of you go on, look at the app, and it'd show you from where you are, from the direction you're entering from. It'd say, hey, you're at seat 117. You're going to look to get through the eastmost gates, and this is the optimized footpath from going to where you are there to your seat selection. And from there, you can look upon having also different amenities as well. So saying from, let's say, if you're going from seat 121 and you want to go to a confectionery stand up at the front, you would go from your seat there up to the left and then go down from there. And this is kind of showing off the 15 shortest pathways from the gates to your seating. And from here you can see that our shortest pathways, we're looking at around 36 meters to an utmost of 44.5. And another use for the TD app rework that we could look to improve on would be the use of push notifications. So as of now, we could look at having operations staff that can use to communicate live updates such as gate openings and closures, queue conditions, looking at alternative entrances if those main entrances do get clogged up, looking to emergency safety notifications and or maintenance and service issues and delays that happen in the event of. Anyway, so the benefits of reworking the TD app is that it provides clear, fast communication during high attendance events. When entrances become busy, visitors can be redirected early and easily to alleviate gate entrances, reducing queue times and relieving pressure on security personnel. By distributing that foot traffic across the venue, congestion decreases, entry size also improve without requiring new infrastructure and any types of big major project reroutes. And combining the pedestrian foot traffic inside and outside the building will be able to reduce the congestion with in and around the building. With the transit line as well, you're getting a reduction of vehicle traffic inside the area, and you're looking to reduce congestion within the building as itself.
And signage. There could be more signage added, more maps added to the exterior of the building too. And those maps will direct visitors to the other gates around the TD Coliseum instead of gates 1, 2, and 3, which already gets much traffic. So adding more signage just make the flow of traffic better, and also give space for citizens walking by, accessing other services in downtown core, and adding more signs inside the interior arena too, so where your sections are and everything too.
Okay, so this proposal is designed with both short-term and long-term. The regional intercept parking acts as a flexible day event. That'll be your short-term strategy to help with congestion downtown. And the long-term solutions will be the TD app that can be continuously improved by user guidance over time. Yes.
Thank you. Any questions?
So, hello everybody. I'm William, Marilou, and Alexis. We're from Université Laval, and we're going to present to you our solution. We called it a dual city geomatic solution for the TD Coliseum. So the challenge, as we got introduced yesterday, was the high volume travel surges during events at the stadium, and causes by the limited urban installation like parking supply that lacks a little bit, not a little bit, that lacks, and the downtown core infrastructure and road around it that was not made to support those volume surges. So we came with the dual resolution approach. We learned that the majority of the attendees at the event came from Hamilton and Toronto for the vast majority. So we came with a solution that will cover the Hamilton part and the Toronto part. So for solution 1, for Hamilton local flow, we're going to focus on local public transit accessibility for the people nearby. And for the Toronto, for Toronto, we're going to focus on behavioral change for the commuters that coming from outside the city. So when we say Toronto, we're talking about people coming from up. So for the Hamilton solution, I will let my teammate do it.
The overall solution we are proposing, our approach focus on the identification of key arterial roads surrounding the stadium. These are major corridors that already play an important role in moving a large number of people. The main idea is to implement temporary bus-only lanes during pre- and post-event time windows. This allows transit to operate more efficiently when demand is highest without requiring permanent change to the road network. The selection of these corridors was based on clear criteria. We considered the width of the road, their proximity to the stadium, traffic volume, and the direction of transit flow. Together, these factors help ensure that the proposed solution is both effective and well adapted to existing conditions. This map shows the road networks in the study area. The roads are shown in black, providing an overall view of the existing street layout. The roads highlighted in red represent corridors with a high volume of traffic, meaning they are major routes used by a large number of people. The roads shown in greens are the corridors selected for the implementation of dedicated bus lane. These routes were chosen because they also carry a high volume of traffic, allowing us to serve the needs of a larger portion of the population. In addition, they meet the criteria we had previously established, including proximity to the stadium, traffic direction, and street width, which make the implementation of a reserved lane realistic. These maps show the existing bus routes that already operate along the roads we are focusing on. It helps us understand how the current transit networks function and how a dedicated bus lane could be integrated efficiently. The maps also show the bus stops, which help identify which stadium gates users can choose depending on where their seats are located inside the stadium. This improves accessibility and facilitates smoother pedestrian movement around the stadium.
Thank you. Okay, so to control the traffic, we came up with a dynamic idea. So the activation of flashing transit signal, like those ones, will be on a pre-event window activated 90 minutes before prior to the event to make sure that the people going to the event can easily go by bus. During the event, we can shut down those signs, and post-event, we're going to allow a 60-minute window to clear the path for the attendees. So so the impact, it will be a real-time redirection of private vehicle traffic to maintain bus priority, and also by that we can dedicate those lanes to guarantee the passage of emergency vehicle during peak congestion. So for a feasibility study, we can use some simulation tool like the Esri tool that we saw this week to model event-day scenarios of a traffic jam and to see if we close that lane, will it be a total disaster or can it be viable for an hour or two? And that's pretty much it for the feasibility study. And then once we identify clearly the road that can be feasible, we're gonna put the physical implementation of those streetlights. And that's a little complementary mobility option that we thought of to another incentive, just to include a bus ticket to your not Apple Wallet, but your wallet with your ticket.
So for Toronto, we talk about it, I will present it quickly, but the idea is an additional parking concept. So there is, we want to intercept people from all of the north of Hamilton before they get to Hamilton with their cars. How do we do that? They need to park somewhere. So we want to encourage, to motivate them to take parking and complete their journey with buses. To incentivize them, we're providing a competitive alternative to the 60-minute plus drive, to get here by car. So this is just an expectation and a proof of concept, but we have thousands of free parking in many stations all the way through the bus go right, and there's also the 16 line who's going from Union to Hamilton. So we have many bus lines. We feel like they're underutilized. So how do we get people to utilize them more? It's a simple concept. We can take cash back on Go Transit ticket. So if you have a ticket for a spectacle at TD Coliseum, you have a cash back 25% or something on the Go ticket. With the promo code, you need to take it at least 40 hours before the show, so we can plan for how many Go buses we needed. And that will enable dynamic capacity planning, because obviously if you have 100, 400, 500 people coming in buses, you can plan, all right, in this hour I need 5 more buses going down from Toronto, and at the end of the show I need 5 more that go up. So that will allow capacity. And rapidly, for the wrap up, we can summarize our strategy. We have a dual approach. We have dynamic infrastructure. We have behavioral incentives to get people to take the transit. And that's the plan. We have a 48-hour redemption window, verify feasibility and use of street volume analysis and transit directional strategy to select the most efficient arterial road and for the dedicated corridor. And thank you. Merci.
Merci beaucoup.
Merci.
Hello, my name is Nicolas, this is Olivier, and this is Samuel. We're going to be talking about how we're going to be optimizing event mobility at TD Coliseum through geospatial multi-criterial analysis.
After analyzing the problematic that was proposed to us, we identified 4 main issues that we want to put on focus and energy on. So the first one is resident quality of life. The second one is accessibility and safety concern. As we know, the flow of incoming people is more gradual, but at the end of the event, the main issue is the high concentration of people. After discussing with our partner at TD Coliseum, we learned that they have only around 800 parking slots surrounding the area of the stadium. So going away for parking will only cause more strain on the existing public transport infrastructure.
So what do we do about these concerns? Well, first of all, we thought about how to get people that needed it out of the city center without putting more strain on the existing infrastructure of public transportation, and doing so without causing more traffic. So we looked at the data of where most people come from in these events that are held at the TD Stadium, and we realized that other than inner city origin, so meaning people that come from the city of Hamilton, around 45% of them come from the city of Toronto. That's when we chose to do a multi-criteria geospatial analysis to determine strategic parking locations.
So where will be the optimal location? Well, we have to take into account a location where people from other city could easily get to, meaning to not cause any unnecessary detours, and it had to be too far from the TD Coliseum, and itself so that the shuttle ride time will be reasonable, and it had to be close to main roads or motorways so that we don't just move the traffic problem from one place to the others, and also the help maintain a good flow of traffic in the area of the selected parking.
So here we have a visual representation of our multi-criteria geospatial analysis. The actual analysis was done in the RStudio with the R program language. We used datasets of Hamilton roads and the greater Toronto Metropolitan area. Also, we used datasets of parking lots in all the different cities in the greater Toronto Metropolitan area. That led us to realize, because most of the data sets of these parkings had some problems, missing data, incomplete information regarding the number of slots or location. So that led us to shift our focus to realize that we could also select promising locations for new parking spots that weren't already established in the optimal area represented here. To determine this optimal area, we use reasonable distances for around the TD Stadium and the main motorways and roads. We established this optimal area between Hamilton and Toronto, keeping in mind the main traffic comes in from Toronto other than the people already in Hamilton. That's where we found the area surrounding the Aldershot train station with the little purple dot. Next to an already existing parking lot for this train station. My colleague is going to go more in depth shortly. However, with the increase of population from around 500,000 and 800,000 in the next decades in Hamilton, the rest of the surrounding areas could see an increase in the population similar to that of the city of Hamilton. With cities like Kitchener, Brantford, and Guelph, where the amount of people coming from these cities could also increase. Our concept can be a proof of concept, actually. If the increasing demand for transportation from the west, these cities in the west of Hamilton, so we could create the need for another shuttle route.
Here we have the Aldershot train station and your potential park and ride or shuttle location, which is in your designated optimal area that we presented in the previous slide. So we will need an area big enough to receive our parking lot. And in addition to the pinpoint area, the zone will also respond to our need in case of growing demand. This location is great because it takes into account people that will arrive by car and those who will also arrive by train. It's also important to mention that this location is in wetland and that the implementation of your parking facility represents the redevelopment of an underutilized site.
But where will we even park the shuttle to close to the TD Coliseum? Well, we will do a temporary street reconfiguration and transit priority. Our partners at TD told us that for some shows that already closed the street for the safety of the pedestrian, the closed street will serve as a temporary transit hub. And then, meaning the entire street section will become a bus-only zone. That zone will also serve as an easy access for emergency services, so that will be easier for them to do crowd management.
Here's are the environmental and community benefits. By adding new transport, we can reduce the air pollution in the center of the city. By this new implement, this will also decrease the traffic in the different area. We also reduce the number of vehicles, so we reduce the noise in this sector. And also the reduction of the stress on the existing public transportation.
So in conclusion, with our shuttle service to Aldershot train, we're not looking to reinvent the wheel, but only to improve what already exists. Thank you.
Thank you.
Laval à Québec et nous sommes en première année de sciences géomatiques qui va nous mener plus tard à être des apporteurs géomètres si tout se passe bien. On participe à l'événement pour en fait approfondir nos connaissances, avoir plus d'expérience dans le milieu, puisque effectivement nous sommes en première année. Et d'une autre part, en fait, c'est de voir différentes visions de la géomatique, puisque au Canada elle diffère entre les provinces. Donc, on va commencer avec une brève présentation de la ville d'Hamilton dans laquelle se déroule notre problématique. Donc, la population qui est d'environ 650 000 habitants. On a une superficie de 1120 km² avec une densité de population de 510 personnes par km². Selon les statistiques reçues, il y a 2346 arrêts d'autobus. Et bon, donc pour la problématique, on a commencé avec une première observation selon les statistiques reçues encore une fois. Donc il y avait en fait le nombre d'utilisateurs d'autobus. On peut voir qu'il n'a pas changé depuis 2014. Donc ça nous amène à nous poser des questions dans le sens est-ce que le monde ne prenne plus l'autobus? Ben en fait, est-ce que le monde ne prenne pas l'autobus? Est-ce que c'est un problème de capacité des autobus? Puisque on sait que la population à Hamilton en fait est dans les plus grandes dans les plus grandes en fait, croissances au Canada. Je laisse la parole à Patrick Mixou.
Thank you. Bonjour. Pour notre, on a aussi vu, on a observé aussi une deuxième observation, c'est que selon une étude, on peut voir que la plupart des gens qui viennent aux événements au TD Coliseum, ils proviennent principalement de Toronto. Puis on peut, selon la première observation qu'on a vue, on peut prétendre que ces usagers-là, pas ces usagers, mais ces gens-là, ils utilisent leur véhicule personnel pour pouvoir se rendre à l'événement. Puis pourquoi on peut prétendre ça? C'est parce que, premièrement, le trajet, ça se fait plus rapide en auto qu'en véhicule en transport. Ça prend à peu près 50 minutes Toronto à Hamilton le trajet, tandis qu'en train ou en autobus, ça peut prendre 1h20. Puis si on regarde aussi le prix, on a pris un véhicule qui consomme plus de 600 km, c'est à peu près 10$ pour faire le trajet, tandis qu'une passe, un ticket en autobus ou en train, c'est à peu près 15$. Fait que pourquoi les gens de Toronto prendraient le transport en commun quand c'est plus convenient et c'est moins cher prendre leur véhicule personnel? Fait qu'on regardait pour une solution alternative pour faire en sorte que ces gens-là soient plus incités à prendre des transports en commun. Parce que si on réduit la circulation près du Colisée, ça va permettre justement à l'accès pour les véhicules d'urgence, meilleur accès. Ça va réduire la congestion pendant les événements. Puis ça va une solution aussi qui permettrait que les gens qui vont à l'événement soient dispersés autour de l'aréna pour rentrer dans les portes d'entrée plutôt que juste dans les 3 portes principales qu'on a vues hier. On avait pensé à 2 options. Une, c'était d'établir une ligne réservée pour les autobus pour accélérer le transport entre Toronto et Hamilton. Puis, une autre option, c'était aussi pendant les événements, c'est de faire du contrôle pour les feux de circulation pour améliorer la fluidité de la circulation sortant après l'événement. Et puis, nous avons vu aussi qu'à Oxford, ils ont établi plusieurs modes de transport en commun. Puis un de ceux-là, c'était le transport par navire. Puis ça avait amélioré ça avait diminué leur trafic de 20% en utilisant une de ces méthodes-là, justement. Puis, ouais. Puis là, ça, c'est... sorry for the crop out the map. C'est une carte qui montre les routes où il y a plus de trafic dans un rayon d'1 kilomètre autour du Colisée. Je vais passer la parole à Félix.
Donc finalement, notre solution afin de régler ces problèmes se tourne vers les navettes. Notre système que nous avons imaginé s'occupe sur 5 stationnements préétablis, où est-ce que 5 navettes vont faire des parcours selon des horaires fixes.
Ces navettes vont être environ aux 15 ou 20 minutes, dépendamment de l'achalandage de certains événements. Le prix des navettes va être inclus dans le billet des utilisateurs du TD Coliseum, afin que le monde qui se transporte en voyage en commun n'ait pas à dépenser une seconde fois pour se redéplacer. Donc, ce que cela permet de faire avec les navettes, c'est que ça réduit énormément le déplacement des voitures tout autour du TD Coliseum, ce qui assure une meilleure sécurité pour tout ce qui est des piétons, une meilleure circulation pour tout ce qui est des véhicules d'urgence. Par la suite, à la fin des événements, toutes les navettes vont se situer autour du TD Coliseum afin de pouvoir apporter chaque monde à leur stationnement prédéfini et pouvoir transporter les gens en toute sécurité. Pourquoi est-ce que nous pensons que c'est une bonne idée? Premièrement, parce que, comme je viens de le mentionner, moins de monde sur les routes veut dire une meilleure sécurité. C'est plus facile pour les gens qui se déplacent, c'est plus facile pour les gens qui marchent. Deuxièmement, les navettes circulent selon des horaires fixes. Alors, c'est pas tout le monde qui arrive en même temps au même gate, ce qui va extrêmement faciliter le travail de tous les employés du TD Coliseum de pouvoir gérer du monde qui sont en batch et non pas tout d'un coup. Troisièmement, moins de personnes sur les routes, comme je l'ai mentionné également. C'est beaucoup plus facile pour que les emergency cars, que ce soit les pompiers, les policiers, les ambulances, tout le monde peut se déplacer plus facilement. Et puis, finalement, ça permet au monde de se stationner plus loin parce que les navettes peuvent aller les chercher plus loin dans les stationnements que tout le monde autour du Coliseum, ce qui est encore une fois meilleur pour tout ce qui est en termes de circulation et de congestion. Donc, voici une carte de quoi ressembleraient les voyages en navette. Et les parkings établis sont en bleu sur la carte juste ici, qui permet aux navettes de se circuler jusqu'à temps de revenir au TD Coliseum. C'est ce qui va faire pour autant le début du show qu'à la fin. Donc, merci énormément à tous nos commanditaires et à vous de nous avoir écoutés.
are here to present our solution for managing event-based mobility at the Coliseum. Our approach includes three principal aspects. First, we focus on we based our reflection on four main issues related to large-scale events, which are event-specific transit operations, pedestrian flow and crowd management, parking pickup, drop-off and curbside management, and traffic flow and safety management. Our approach includes three principal aspects. First, we focus on public transit access with a spatial analysis and the deployment of a website/mobile application to optimize public transportation. Next, we address pedestrian management before and after the event through indicator signage and optimize security and police deployment. Finally, we aim to ensure efficient dispersal through organized pre- and post-show gathering at the Jackson Square and the optimization of York Boulevard access.
Okay, so regarding the spatial analysis, we started with the data collection. Our solution being mostly aimed toward reducing egress traffic congestion around TD Coliseum. We decided to use larger scale data. So we used the Statistics Canada General Transit Feed Specification, which offered a geo package for public transit network across the country. Just used a quick clip to just keep the zone we wanted. Then, using QGIS, we extracted the parking lots from OpenStreetMap using the quick USM plugin and just doing a quick query. After that, we normalized the projections to make precise calculation, removed overlapping routes, and extracted non-private parking lots. We then calculated a new field to have the lots area, selected the greater than 15,000 square meters parking lots. We then made a proximity analysis using 200 meters buffer on the routes and just intersecting that with the parking lots. That all of that made choosing best parking lots for every area easier.
So with this selection of parking lots that we did, we addressed the issue of congestion since we use parking lots around and peripheral of the cities of Hamilton, of course. And then our solutions consist of a website that can be accessed after the purchase of a ticket. It's online, and it will allow the online reservations of those spots. So basically, it will require a partnership with the parking lot owners to calculate the amount of spots and the disponibility for the events, of course. But the centralization of our user in outskirts of the city and communications of the system reservation would facilitate decisions making regarding the use of shuttle system that we will incorporate to go from those parking lots to the events at TD Coliseum. And then for the egress, there would just be shuttles that would flow every 5 to 10 minutes to make the people go from TD Coliseum to their parking lots efficiently. And then as time will go on, people will realize that it's really more efficient as you know where you're going, and then people will use it more and more, and the congestion will really lower after time. And no, it's not finished. So basically we know that there's a lot of pedestrians, and now those pedestrians will just go out right at the gates, and then they can go limit the time of walking, and we can incentivize people with discounts. And there's an example through Shiny what we could do, for example. So here's a Shiny ad that we did. So as you can see, is it possible?
Thanks.
Well, basically we can pick your event, and there's different parking disponibilities based on where the parking lots are, and then you can select what parking lots you want to use. There's an arrival time, so you will be able to know when people will come at those spots, and then you can see when you're in admin mode, you can access the report and see how many people will go to this parking lot at this hour and do a shuttle in concordance to that. So yeah, and then you can see update depending, and it's a work in progress. As we didn't have time to work more on it, but like it's an idea of what we can do. Yeah.
During Ingress, many attendees gather at gates 1, 2, and 3 on Bay Street North. To encourage people to use the gates further along York Boulevard, we propose installing screens that display waiting time at all entrances, along with real-time images of less crowded gates. This solution aims to optimize queues and reduce waiting times using visual indicators. We aim to enhance existing measures such as security and police deployment by leveraging the camera monitoring system described earlier to assist with crowd dispersal.
With the goal of exploiting gate 12 and 13, making ingress and egress less condensed, we suggest holding pre- and post-show gathering on the Jackson Square. So our suggestion comes with the optimization of the accessibility to York Boulevard when exiting from gate 12 and 13. The following plan shows the general idea. Attendees arriving and exiting would have access to food courts, sanitation, and any kind of show to be held on the Jackson Square. We can also see in the purple region where we suggest to optimize access to York Boulevard. So we could do the shuttle service on this area, eventually closing a lane of the boulevard just to facilitate the egress where people leave.
And we'll go real quick on the timeline, but basically it's people buy their tickets, we know where they are, we can do the shuttle services efficiently, and then they can return during their egress to their parking lots. Thanks.
Finally, system monitoring and data collection in database will allow first efficient scalability following week-to-week number and location of users, and secondly, management can make data-supported decisions on where to offer more or less service.
Yeah, so thank you.
Kim, maybe with the benefits.
Yeah, there's a lot of benefits for attendees, resident, and emergency responder. For attendees, with the improvement of the experience and reduced waiting times. For the resident, with less congestion and smoother local traffic. And finally, for the emergency responder, with faster and easier access. If you have any questions,
Don't hesitate. Thank you.
Thanks.